Hi, fifth period. So we're going to continue with our notes from yesterday on the very front page where we're working with our unit circle. So I'm going to talk about two different topics. My first topic is how do we fill in these missing coordinates all the way around the circle? The second thing we're going to talk about is inside the packet. We're going to discuss how to find sine, cosine, and tangent of some of these different radian measures using only our unit circle. So let's get started. I want to first remind you of something before break. So down here at the bottom, if you could just draw in a 30-degree angle and make it a 30, 60, 90 triangle. So this would be my smaller 30-degree angle, my medium 60-degree angle, and my 90-degree angle. If you remember when we did 30, 60, 90 triangles, this was my short side, this was my hypotenuse, and this guy was called my long side. And we had two formulas. One formula said the hypotenuse was equal to 2 times the short side. The other formula is that the long side equaled rad 3 times the short side. So let's hypothetically say that our hypotenuse is going to be equal to 1. So I'm just telling you right now, we're going to use the hypotenuse is equal to 1. So what would the other sides be? Well, if the hypotenuse was 1, it looks like for my short side, I would divide both sides by 2, and I would get that 1/2 equals my short side. So this would be 1/2 in length. So if my short side was 1/2, then my long side would equal rad 3 times 1/2, or in this case, this is over 1. My long side would be rad 3 over 2. So this length would be rad 3 over 2. So I'm going to now use this triangle up in my unit circle. And if you notice, I made one that I can move up above. This triangle is a 30, 60, 90. This is my 30-degree angle, my 60-degree angle, and my 90-degree angle. And notice what I wrote on here are that my side lengths of 1, 1/2, and rad 3 over 2. So one of the reasons why this is called a unit circle is that the radius is 1 radii, 1 unit. And so my radius from the center to the edge of this circle, this point right here, is 1. It is 1 unit to here, to here, to here, to here. So all these different radii of my circles, they're all 1 unit in length. So if I look at this 30-degree angle that we wrote in yesterday, and if I think about it as fitting in this 30, 60, 90 triangle, I'm now going to think about this. If I remove the circle from my mind and think about it as a coordinate grid of vertical and horizontal lines, this coordinate right here has an x distance, a distance along the x-axis of rad 3 over 2. So to get to this coordinate, I am rad 3 over 2 units on the x-axis, rad 3 over 2. I am up on the y-axis 1/2 of a unit, 1/2 of a unit. And my hypotenuse, which is a radii, is 1 unit. So this coordinate, if this was full of horizontal and vertical lines, this coordinate would be at rad 3 over 2 units from the origin and would be up 1/2 unit from the origin. I can do the same thing to get the coordinates of this coordinate up here. However, I need to turn my triangle because now that's a 60-degree angle. So I need my 60-degree angle at the origin. This would be my 30 and this would be my 90. And if I want to figure out the coordinates of this point right here, again, I need to know how far over it is on the x-axis and how far up it is on the y-axis. So if I think about this 30, 60, 90 triangle in here with a hypotenuse of 1, since the radius of my circle is 1 unit, it looks like I'd be over 1/2 a unit on the x-axis, and I would be up rad 3 over 2 units up the y-axis. So then we have this coordinate. This coordinate was made with the 45-degree angle. So let's go back down to the bottom of our notes and sketch in a 45, 45, 90 triangle. This triangle, remember, is isosceles. So these guys are equal. This is my 90, this is my hypotenuse, and we called the other two legs. And we only had one relationship in a 45, 45, 90. It was that the hypotenuse is equal to rad 2 times a leg. So again, I'm going to say my hypotenuse is 1. And this is because the radius of my circle is also 1 unit. So if I say that the hypotenuse is 1, then it is equal to rad 2 times a leg. In order to find the leg, I have to divide by the square root of 2 on both sides. So a leg equals 1 divided by the square root of 2. If you remember, we can't divide by a radical. So I'm going to have to rationalize this by multiplying by rad 2 over rad 2. And I'm going to get rad 2 over 2. When I multiply 2 square roots, I just get that number. So I have a little triangle all set up just like this, where my legs are rad 2 over 2, and my hypotenuse is 1. So that's this pink triangle. So going back up to my unit circle, if I put my hypotenuse, which is 1 unit, along the hypotenuse here, I can see that I am rad 2 over 2 units over in the x direction. So the coordinate, the x coordinate of this guy would be rad 2 over 2. And I can see that I am rad 2 over 2 units up the y-axis. And so the coordinates of this coordinate right here would be rad 2 over 2 and rad 2 over 2. You might think that we would go around the whole circle with our pink triangles, figuring out what all of our coordinates are. But we actually don't have to do this. If you memorize these 3 coordinates, so you memorize, and notice that there's only 3 numbers here. The numbers are 1/2, the numbers are rad 2 over 2, and the numbers are rad 3 over 2. So if you memorize these 3 coordinates, you can use symmetry to get all the others. You have to remember some stuff about a coordinate graph. In the first quadrant, your x and your y values are all positive. Notice that these are both positive numbers. However, in the second quadrant, your x value is negative. This is the negative x-axis, and when you go up, your y values are positive. In the third quadrant, both my x and my y values are negative in the third quadrant. And in the fourth quadrant, my x values are positive, however, my y values are negative. So on this one, if you would imagine pushing this coordinate over to the other side of the y-axis, it has complete symmetry. It's the same distance away in the x direction, and it's the same height on the y-axis. It's really the same values, except I went over negative 1/2 on the x-axis, and I went up rad 3 over 2 units on the y-axis. I can push this coordinate over to this side as well and use my symmetry. This height is the same on both sides. I am rad 2 over 2 units high on my y-axis. The distance from the origin is the same. However, when I move rad 2 over 2 units to the left, it's negative. So I'd have negative rad 2 over 2. And finally, I'm going to push these coordinates over as well. So the same idea is I'm negative rad 3 over 2 units in the x direction, and I am up the same half unit on the y. So the first quadrant, both my x and y coordinates are positive, and in my second quadrant, my x is negative and my y is positive. I'm going to use that same thinking to move these same coordinates down to the third quadrant. So here, if I push this coordinate down to the third quadrant, I'm exactly the same distance over on the x-axis. I'm negative 1/2 units over. And I'm actually exactly the same distance away from the x-axis, sorry. I'm the same distance away from the x-axis. However, when I move down rad 3 over 2 units, it's negative. So this would be negative rad 3 over 2. Notice that both my x and y coordinates are negative, as they are in the third quadrant. Let's push this one down, and it's the same thing. It will be negative rad 2 over 2 units in the x direction, and I'm now down rad 2 over 2 units in the y direction. And then finally, we'll push this coordinate down as well. And I am negative rad 3 over 2 units in the x direction, and I am a half unit in the y direction, and it's a negative 1/2. So in the third quadrant, both my x and y coordinates are negative. And finally, I'm going to push them all over to my fourth quadrant. In the fourth quadrant, all my x distances will be positive, all my y distances will be negative. So when I push this coordinate over, I notice that I'm going to have a positive rad 3 over 2, but a negative 1/2 units down the y-axis. When I push this coordinate over, I will be positive rad 2 over 2 units in the x direction, but I will be negative rad 2 over 2 units in the y direction. And finally, I will push this coordinate over as well, and I will have positive 1/2 and negative rad 3 over 2 for all the reasons that we were just talking about. So I filled in all the coordinates except what I'd like to think of as the easy coordinates, the ones on my axes. So now, if we think about our unit circle as having a radius of 1, then this coordinate right here is 1 unit in the x direction, and I haven't went up or down, so it's 0. It's an x-intercept if you want to think about it that way. Here, if you notice that I have not moved left or right, so my x coordinate would be 1, and then I am up 1 unit or 1 radii in the y direction. And to get this coordinate right here, the same kind of logic, I am going over 1 unit, but it's negative 1 in the x direction. So I would have a negative 1, and I haven't went up or down in the y at all, so my y coordinate would be 0. And lastly, I haven't shifted left or right at all. My x coordinate of this coordinate right here would be 0, and I'm down 1 radius, so that would be negative 1 units. You've now filled in an entire unit circle. You have the degrees from yesterday, you have the matching radian measure from yesterday, and you've now filled in the coordinates on my unit circle. So you can practice this on your own time inside the packet. There's a completely blank one. You can also print these blank unit circles in the locker. You will have to fill in an entire unit circle on your own. There are a lot of tricks to this that can make memorizing it easier. There's a few videos in the locker with some of the tricks and songs if you want to check it out, and I'll be happy to share some with you when I see you on Thursday. So that was the first part of our lesson today. The second part of our lesson today is inside your packet. If you open it up to where it says 7.9, the trig functions. This is where you're going to first get an idea of how you actually use the unit circle in trigonometry. And next year in your classes, you're going to expand on that, because this year we're only going to work on cosine, sine, and tangent. Next year you're going to add 3 other functions, cosecant, secant, and cotangent. And you'll be doing other work with this unit circle as well. So for starters, on our unit circle, we need to talk about our trig functions. And I want to remind you of sine, cosine, and tangent. So in a circle, if this is theta right here, then this is my side opposite, this is my side adjacent, and this is my hypotenuse. And I want to remind you from what we did before break that sine theta was equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and tangent theta was equal to opposite over adjacent. So in the unit circle problems, remember our unit circle has a radius of 1, my hypotenuse is always 1 unit. So when I get ready to do this sine, cosine, and theta, this opposite side was always my height in the y direction. This adjacent side of my triangles was always the length in the x direction. So if I could pull out my 2 pink triangles again, I'd like to remind you that this was the length in the x direction, and this is the height in the y direction. So my opposite side was my y value, and my adjacent side was my x value, and my hypotenuse was 1. Same thing here. My adjacent side was my x value. My opposite side is my y value, and my hypotenuse is 1. So we're going to use that when I talk about my trig functions. So in this picture, I'm going to talk about my sine of theta is going to be equal to opposite over hypotenuse. In this case, it's the y value divided by 1, or sine theta will be equal to whatever your y coordinate is. Cosine theta, using the unit circle, is adjacent over hypotenuse. That was my x coordinate over 1, or my cosine theta will be equal to whatever my x coordinate is. And finally, tangent theta. Tangent theta is opposite over adjacent. So in this case, my tangent theta will be my y coordinate divided by my x coordinate. And we're going to look at a few examples of that. So we're going to do this with 4 different values from our unit circle. So you'll need to have your unit circle handy. The first one we're going to do is pi over 3. So if I go back to my unit circle and I go to pi over 3, which is equivalent to 60 degrees, the coordinate, the xy coordinate for pi over 3 was 1/2 rad 3 over 2. So the coordinate that goes with this one is 1/2 rad 3 over 2. So now I'm going to write down what the sine of pi over 3 is. The sine of pi over 3 is going to be equal to whatever the y coordinate is. In this case, that's rad 3 over 2. Cosine of pi over 3 will be equal to whatever the x coordinate is. In this case, it's 1/2. And if I could put my 60-degree triangle back up here, you can see that in your 60-degree triangle, indeed, the opposite, rad 3 over 2, divided by hypotenuse, was rad 3 over 2. And my adjacent, 1/2, divided by hypotenuse, which was 1, was 1/2. So now I have to do tangent. Sometimes there's some work to do when you do tangent. In this case, it's my y coordinate divided by my x coordinate. It is y divided by x. It's my opposite side divided by my adjacent side. So in this case, it's rad 3 over 2 divided by 1/2. So when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So this is rad 3 over 2 times 1/2. In this case, it's rad 3 over 4. Oh, I didn't flip it to the reciprocal. Sorry. Can you guys not write that? So in this problem, so sorry about that. When you're dividing by a fraction, it's the same thing as multiplying by the reciprocal, but I did not flip it. So instead of dividing by 1/2, I'm going to multiply by 2 over 1. And then my 2's cancel, and I just get rad 3, which I knew was the answer for tangent of pi over 3, and that's why the other problem threw me off. Sorry about that. So these would be the 3 answers, and on the quiz, you're going to get something that'll say, what's cosine of 1/3? And you're going to be able to use your unit circle, and if you know cosine is your x coordinate, you're simply going to write a 1/2 there, and you're going to be done with the problem. So let's say sine of pi over 2 is on the quiz. Well, you're going to use your unit circle, and you're going to look at pi over 2. And pi over 2 was 90 degrees, and the coordinate was 0, 1. So you're going to look at your coordinate 0, 1, and you're going to memorize that sine is equal to your y value, and you're simply going to write 1. And you'd be done with that problem. And if it had said cosine of pi over 2, then you would be writing down your x-coordinate. And in this case, my x-coordinate is 0. And careful, when you do tangent of pi over 2, in this case, that is my y divided by my x. So you have 1 divided by 0. And you can't divide by 0. Anything divided by 0 is undefined. And you would write undefined. You can, of course, check all of these on your calculator in radian mode, and I will show that to you on Thursday in class. So let's continue with pi over 4. We're going to be finding sine of pi over 4, cosine of pi over 4, and tangent of pi over 4. If I was with you in class, this is where I would let you guys just find the answers for me. So you need to go back and look at your pi over 4. That's 45 degrees. And you need to know the coordinate at 45 degrees is rad 2 over 2, rad 2 over 2. Rad 2 over 2, rad 2 over 2. So my sine is equal to my y value, rad 2 over 2. My cosine is equal to my x coordinate, rad 2 over 2. And tangent is y divided by x, which in this case, everything cancels to 1. When you divide something by itself, they cancel, and your tangent of pi over 4 would be equal to 1. The last one is 0 radians. So if you look back at your unit circle, for 0, you're going to find your coordinate is 1, 0. So to do sine of 0, sine is equal to your y value, so sine of 0 is 0. Cosine of 0 would be your x-coordinate, and your x-coordinate is 1. And lastly, tangent is equal to 0 over 1, and 0 divided by 1 is 0. 0 can be divided by anything. You just can't divide by 0. So there are some times when it's a little trickier. You have a little bit of math to do as far as multiplying by the reciprocals, but it's nothing that you guys can't handle really well, I'm sure. So these next 4, you're going to complete in your groups. Actually, let me look at this one with you before I leave you. This is negative pi over 2. So you're going to use this same unit circle. You don't really need to make a negative unit circle unless you want to. But what I would do is just do reverse movement. So for example, if this is pi over 2, sorry, let me move it down. If this is pi over 2 in the positive direction, I know that 90 degrees is pi over 2 in the negative direction. So negative pi over 2 is down here. This is negative pi over 2. The coordinate that goes with negative pi over 2 is 0, negative 1. So this guy has the coordinate 0, negative 1. So what it said is to find sine of negative pi over 2. Sine is my y value. So in this case, it would be equal to negative 1. Okay, ladies and gentlemen, so do these 3 and compare with your group members. The answers are on the board. You can check your answers. And then use your time in class today to finish the second page. This is actually work from also before break. So if you get out your notes before break, we talked about drawing angles. This is where you have to use your arrow to show me which direction you go. And then write each angle in radian measure as a multiple of pi. You're converting degrees to radians. That is also on the notes from before break. It says write each angle in degree measure. So these are all radians. You need to convert from radians to degrees. Again, that's on the notes from before break. So this is what we worked on yesterday, finding one positive and one negative coterminal angle. So you're given radians and degrees, and you have to find one positive and one negative coterminal angle. It says sketch the following angles, much like up at the top, but you're actually going to find the reference angle, which is another topic that we learned yesterday. It's in your notes from what we did in the class yesterday on this page. And then lastly, check your answers on this page up on the board, and if you're doing okay, then you can begin working on the back 2 pages, which is our review for the quiz. If you can answer all of these questions, then you would be more than ready for our quiz that we're going to have on the unit circle. So work on those and check your answers as you go along, correcting any mistakes that you're making, and we'll go over anything that you had trouble on Thursday. Thank you so much.